Okay. So example. Solve sine square root of x, 2 sine square root of x minus sine of x equal to 0. Find all solutions in the interval 0 to 2. Solution. Okay, let's try to solve this first. The first thing that you should be able to do is to change this sine squared of x as sine x squared. See, I said sine squared of x is a shorthand for sine x squared. So you have to go back with that. Then you see that these two terms have a common factor. What is that? Sine x is the common factor. So I can factor that out. And let's think about what's left inside. It's 2 sine x minus 1 equal to 0. Right? If you're not so clear how I got from here to there, try multiplying this out. If you multiply sine x times 2 sine x, what do you get? You get 2 times sine x squared, right? If you do sine x times negative 1, you get negative sine x. So these two are exactly the same thing. Okay? Then, when you have two things multiplied to 0, it's either sine x is equal to 0 or 2 sine x minus 1 is equal to 0. Now 2 sine x minus 1 equal to 0 can be further solved as 2 sine of x equal to 1, sine of x equal to 1/2. So solution of this should either satisfy sine of x equal to 0 or sine of x equal to 1/2. We have to figure out those values of x. How do we do that? We have to go to the graph. So let's go to the graph. Here's 2 pi, here's pi over 2, here's 3 pi over 2. It starts from 0, 1, 0, negative 1, 0. Look how I plot these points before I draw the graph. That actually makes the graph much nicer. And when you have a good graph, that's easy to read these values. Okay? Now this is the graph of sine x on this interval 0 to 2 pi. Isn't that right? Okay. Now let's think about sine x equal to 0. When is the value of sine equal to 0? At here, here, and here. So for x equal to 0, pi, and 2 pi, sine x is equal to 0. Okay, so these are the places where the value of sine is 0. See, because this is the graph of y equals to sine of x, if you want to know when sine x is equal to 0, you're looking for the y value being 0, which is the height, right? Y being 0 means you're looking for the place on the graph where it exactly hits the x-axis. And you can see that this graph hits the x-axis exactly at these 3 points. Okay? So that's 3 solutions so far, but that's not all, because there are values of x where it will hit exactly 1/2, right? So let's think about that. When does it hit 1/2? In other words, because this is the graph of y equals sine x, the question is, when does the height become exactly 1/2? Right? And we should go back and think about those 3 special angle values: small, medium, large, large, medium, small. Okay, and we see that because the 1/2 is the small value, we know that this one and that one, we need the red one. We know that this one here and that one here, those are the places where the sine becomes exactly 1/2. Right? So we have to figure out what this angle is, what that angle is. well, we already know that this is 30, 30, 45, 60, right? And then this is like coming from 180, this is 180 minus 30, 180 minus 45, 180 minus 60. So this being 180 minus 30, what is this angle? 150, right? So we know in terms of angles, it's 30 degrees and 150 degrees, right? However, in calculus, I'm going to explain the reason much later in the class, we will prefer using the radians over degrees. Okay? There's a reason for that in calculus. I can't explain it at this point. Okay? So 30 degrees should be changed into radians as what? Pi over 6, because pi is 180 degrees. 180 degrees divided by 6 gives you 30 degrees. And because 150 is 5 times the 30 degrees, it's 5 times pi over 6. Okay? So the final answer is these two attached together. So the final answer is pi over 6, 5 pi over 6, 0, pi, 2 pi. These 5 are all the solution of this equation.